So this is the mathematical modeling of my DC motor. So now I'm going to just write it in my MATLAB and solve it. Directly I'm going to write this equation and to solve it in my MATLAB. Or otherwise, in a Simulink, what is the advantage of a Simulink? It's a drag and drop modeling. Like my LabVIEW, I don't want to see in my MATLAB everything. If I want to integrate, I need to type my commands. So right, instead of typing commands, I'm going to give a physical modeling, or I'm going to say simulated modeling like my LabVIEW. It is a drag and drop method will be utilized to derive this modeling of this mathematical modeling of of any component instead of writing as a mathematical equation in a MATLAB or your commands. I'm going to derive as a blocks or models in a Simulink. So to start my Simulink, I'm going to use two different methods. So before going to start, you understood about the mathematical modeling, right? Okay, can we go for your Simulink?
Okay, sir.
Okay, to start my Simulink, I can start my Simulink in two ways. By typing Simulink in my command window, so I can able to start my Simulink, or I can find your Simulink tab in my home window. Okay, in a home window, I can find my Simulink tab. Either I was clicking the Simulink, I can open my Simulink panel, or I going to go for my Simulink typing Simulink command. Okay, blank model. After going for a king, I'm going to give a blank model, create my blank model. After creating a blank model, now the blank model is created. Now I need to take out my components. Is it or not? To take out my components, so I'm going to use a library browser. Library browser, which is going to have all my model components are we can find it in the library browser, or I can also type it in the window also. I can type whatever the components are required. I can directly in the window. I'll show it in the practice session. Okay, so drag and drop the components. So I have all the components are available in my library. There are different hierarchies here. Commonly used block, continuous. So we are using continuous mode, discrete mode, dashboard, and logical and bit operations, lookup, math operations. Okay, more important is sinks and sources. Sink is nothing but which is going to be grounds, the grounding terminal, or which is going to be the terminal which is going to be given its output. Okay, it's going to be say its output. It's simply say sources are going to be say is a input supply. So sources are the voltages, DC voltage, AC voltages. Everything is coming under your sources. Sinks are my output. Sources are input, and sinks are called output components will be available in my things. Okay, and these are the components are required for my from my library for browser for this DC motor modeling. So I'm going to have a first the equation is going to have a BS. Is it on a BS is nothing but my voltage supply. BS is required, and I need a gain. Okay, this is going to be stepped input is nothing but if 5 volt is given, it will be having a 5 or a 0. Okay, it will have a stepped input, square wave input will be given, or the discrete type of event will be given. Okay, next is my gain component. Okay, next this gain is nothing but it's simply going to say product or multiplication. Okay, so this gain is nothing but whatever the gain from components constant is given in this. So whenever the input is coming, it is multiplied by the constant it is giving. Okay, if gain is given 1, so if I was giving input as Vs into 1 is equal to Vs is nothing but supply voltage. So 5 into 1 is equal to 5. If I going to give gain factor as a 2, 5 into 2 is nothing but 10. So gain is nothing but a multiplication factor with a constant. Okay, I don't have a multiplication, but multiplying two other components. Here it is a multiplying the constant with the input. Okay, whatever the input is coming, I'm going to multiply that input with a constant value. So I'm going to call it as a gain. Gaining the input is going to gaining the value, whatever the things, it is going to call as a amplifier. I'm going to say whatever value is coming, it is amplifying the value. Okay, if it is minus, it is going to de-amplify. If it is positive, it is going to increase the value. Okay, next is the integrator. It is shown as a 1 by s set on. We're going to use the two other components, w of t and I of t. Okay, we have omega. W of t is nothing but omega of t and I of t. Here two integrators are used. So after all these things, I need to see through a window. I need to see the output as a window. So I'm going to use a scope. Scope is nothing but it is going to show you a graphical structure, or your I'm going to say show the uh, graph of my output. Okay, so this is going to, so I have a two outputs. One is omega out and current output. Okay, and next is my add additional blocker. So what is here? Vx plus Vs is equal to I into R plus L into di by dt plus Vs. So I'm going to add three components. So I need a add, which is going to available in my math block. Other components can be available in the commonly used block. Your voltage supply will be available in the source block. Okay, so in add block, what is the thing is, naturally, so add block will be coming with two additions or two number of additions only. You can able to add only two other. If you want to add three other components, just double click the block and change that how many symbols, plus and plus and plus. So again, plus plus minus. So what this means, it can add a two component and subtract the value from this. So this math block can be used to go on to my properties. Okay, these are the blocks I'm going to use it in my browser. Okay, this is my Simulink model. So I can directly go to the practical section and I'll come again for this thing. Okay. Okay, here is my thing is available. Can you able to see that Simulink? Or I will increase the font size. Okay, Simulink is here. So just type Simulink and give enter, or you can see a block is there in my top window. Go to Simulink and give this. So I'll be having my model. So I was going to open my blank model. Okay, create a model. Can you able to see my Simulink window?
Yes, sir.
So the command window, no, sir?
No, the Simulink window.
No, sir.
No,
No, sir.
Okay, because I have doubt of that one. Okay, now you're able to see the Simulink window.
Yes, sir.
Okay, fine. This is my Simulink window. So I can either go in a two different way. Like I can go for library browser. So okay, now I'll show the library browser and later I'll use the thing, because I cannot able to switch over between again and again with the screen sharing, because now the library browser will not visible. Is it visible? I don't think it will be visible.
Which one, sir? It's showing model browser in the corner, sir.
Okay, now
Library browser, yes, sir.
okay, and so the library browser is there, is it or not? So from this library browser, I can take my blocks, commonly used blocks. So I have a commonly, in a general, what are the blocks are used? It is going to be having integrator. You will be having my scopes, okay, and your product multiplication, addition, input, supply, constant. Everything was available in my commonly used blocks. Okay, and sources will be available in my see sources. I have all my inputs. Okay, so it's a band limit, white noise, a chip signal. These are the noises I'm going to add it, clock, or I'm going to give a constant to my output input. So what I needed, VS is required, is it or not? So I'm going to go for my step input. So even go for a step, select my step, drag and drop it here. Drag and drop it my model window. I hope model window will not visible to you. So I'll change it my. Okay, now you have seen my model window.
Yes, sir.
Okay, now this whenever I was dragging and dropping, your thing is visible. Okay. So now I add a stepped input. Is it or not? So now this stepped input is nothing but my VS. So I can change my name of my model as VS. This is my supply voltage. So I'm going to give it, okay. Before going to my supply, what is my final thing I needed? I need I of t. Okay, I need to find I of t is my final thing. Okay, so to find my I of t, so what I need? I need an integrator. So I of t is nothing but integrating my integrator. So type, just double click on the model window so I can able to get my annotate mode. So here I'm going to type integrator. Okay, I'm going to have my integrator. So label the integrator. What is the name of this integrator? I of t. Okay, so this integrator is done. So just a minute. Okay, these are my two equations. I need to put onto my thing. Can I able to see the equation? So I need to I of t to be derived. Is it or not? For deriving I of t, what is I needed? Integrating of di of dt. Okay, so I will be getting I of t. For this I of t, I needed to integrate Vx. Say Vs is my voltage supply minus R into I of t. Is it or not? R into I of t I should go for that. So R is a gain. I going to add it. So add my gain factor. Gain is 1. Let us have replace the gain factor as R. Okay, and next component I need. So what is this? Okay, what is the input for my thing? So I need R into I of t. Gain is Z or not? So my input should be. Okay, so what is my output of this gain? R into the whatever the integrator I of t. So whatever the value comes, the I of t into R. That is my R into I of t. Okay, and I needed next what is there? Minus Ka into omega of t. Okay, what is that? Ka into omega of t is nothing but my Kb into omega of t is nothing but back EMF. Is it or not? So I need to have one more. I need to have a gain factor. What is the name of this? KB. Okay, so what is the thing is KB into omega of t. Omega of t I have not derived it, so I need a, so how to get a omega of t? Omega of t is equal to integral of kt by IL into I of t. Is it or not? So I'm going to get a integral. Is it or not? So add one more integral. Okay, so what is the initial condition as 0? No problem with that. It will take a default as 0. So I'm going to take integrator of what is this? Mu of t. Okay, it's a integral of omega of t. So omega of t integral, what is my for the input for my omega of t integral? Kt into IL. So I add one more gain. So I'm just going to copy this and paste it and replace the value of thing is Kt divided by IL. Okay, so I can add a simple, moment of inertia is also constant, is it or not? Moment of inertia will also not change. So I'm going to have a moment of inertia IL, okay, Kt by IL. So what is a Kt by IL? Which is going to be, so for multiply by I of t, is it or not? So I'm going to get an input from my Kt by IL. So after Kt by IL, so what is my output? I of t into Kt by IL, which is going to be given to my input for my integral of omega of t. Is it or not? Integral of d omega of t. So what is my output from this? I'll be getting a omega of t is my output. Is it or not? So output is omega of t. So that I'm going to fetch it to my kb. So what is my output of here? Kb into omega of t. Is it or not? So kb into omega of t is the thing, but whatever I required. So I need, so what is this? So what is this? I need add all these components. Is it or not? So I need a one adder. So whenever it's coming, it will have a plus and plus. So I can change what are components. When I add 3 plus, what is added? Three component can be added in my components. So now I'm going to add my 3 components. Okay, what are the components? First, my Vs is added. Okay, next, what is there? Vs minus R into I of t. Okay, either I can change it here itself minus, or I can change in the component there also, no problem. So now I'm going to minus R into I of t. Then I'm going to have a Ka into omega of t. Is it or not? So Kb into omega of t. So this is my Kb into omega of t. So I'm going to add all my circuit to my adder circuit. Then what is happening? I should divide the total component by a L. So I add one more gain. One by L. Okay, it's the inductance 1 by L. So what is happening now? I'm going to give it to here, and this is going to be given to my 1 by S. Okay, so now I got the 2 different things. See, I can able to. So now this work is done. Now I need to see the waveform. Okay, how to see the waveform with the help of scope. COPE. Go to scope. So I need to check I of t. Okay. So I can say it is a I out or the RPM or the force. Okay. And I need to go for my omega out. Omega is nothing but my angular things. Where is omega of t? This is where my thing. Okay. So copy. So this is where my equation is followed. So you got it how this Simulink model is derived. Okay. Now I'm going to comment it out. Can you able to see the screen? So what is happening? Whenever the motor start to run, so initially I of what is I of t is 0 and start to gradually, it start to gradually increase. Is it or not? This start to gradually increases as my motor is keep on running. Okay.